Today's lesson is over graphing rational functions, and this is what rational functions look like. So in order to find the wholes, you're going to factor. Whatever cancels out, we're going to set it equal to 0 and solve. So your first step is to always factor a rational problem. So the numerator, this is a difference of squares. So the numerator, if you factor it, it will be x plus 2 and x minus 2. The denominator, if you factor it, you need to think of two numbers that multiply to negative 14 but add to 5. That is a 7 and a 2. A negative 2. 7 times negative 2 is negative 14, and 7 minus 2 is 5. So this is your problem fully factored. And if you notice, this factor cancels out with this factor. They're both an x minus 2, so those cancel out. So to find your wholes, you factor. Whatever cancels out, you're going to set it equal to 0 and solve. So the x minus 2's are what canceled out. We're going to set x minus 2 equal to 0 and then solve it. So you would just add 2 to both sides and you get x equals 2. So that is the x value of your whole. To find the y value of your whole, just plug this 2 into what's left over. So if you plug in a 2 right here, 2 plus 2, you get 4. And plug in a 2 here, 2 plus 7 is 9. So this is the location of your whole. Okay? So this is your simplified rational function. Those were canceled out. This is now what we're focusing on. To find the x-intercepts, you're going to set the numerator equal to 0 and solve. So this is your numerator, x plus 2. Another word for x-intercept is zeros. So set x plus 2, that is your numerator. Set it equal to 0 and solve. So you would subtract 2 from both sides and you get negative 2. And the x-intercept is a point. So you have 1, 0 at negative 2, 0. Okay? Next, we're going to find the vertical asymptote. To find the vertical asymptote, you set the denominator equal to 0 and solve. So this is your denominator, x plus 7. If you set that equal to 0, you'll get x equals negative 7. That is your vertical asymptote. We set this denominator equal to 0 and you solve. So subtract 7, you get x is equal to negative 7. So if I were to graph this, I would go to negative 7. Here's negative 7. I'm going to draw a line through it. This is my vertical asymptote. It's at x equals negative 7. Also, I have a 0 at negative 2. So at negative 2, I'll put my x-intercept right there. Okay, next. My y-intercept. How do we find the y-intercept? Okay, so to find the y-intercept, you just plug in zeros. So my y-intercept, if I plug in a 0 here and a 0 here, you're just left with 2 over 7. So that is my y-intercept. 0, 2 over 7, 2 sevenths. Okay, and if I were to graph that over here, your y-intercept is at 0, 2 sevenths. So I'm just going to estimate it and put it right there. 2 sevenths. It's between 0 and 1. Okay, now let's find the horizontal asymptote. Now the horizontal asymptote, if your rational function is big on the bottom, your asymptote is 0. Now the mnemonic that you used in Algebra 2 was if it's big on bottom, it's 0, Bobo. If it is big on top, you have no horizontal asymptote. You guys called this bottom last year, the mnemonic. Your last one, if the exponents are the same, divide coefficients. You guys called this EATS DC last year in Algebra 2. So some examples of these. A big on bottom could be x plus 2 and then x squared plus 4x plus 5. See how the exponent here is a 2, but the exponent here you can imagine a 1. So this is bigger on the bottom. If it's bigger on the bottom, your horizontal asymptote is y equals 0. If it was big on top, so say this was reversed and the bigger exponent is on the top, you don't have one. It's none. No horizontal asymptote. And if the exponents are the same, such as x plus 2 over an x plus 5, these both have an exponent of 1. So if they're the same, you would divide the coefficients. So say the coefficient are just 1s. That means your horizontal asymptote is at y equals 1. If this was a 1 and this was a 2, it would be 1 over 2. It's whatever the coefficients are. Okay, so that is how you find the horizontal asymptote. So let's go back to our problem. The horizontal asymptote, here, it looks like our exponents are the same. You have an x on top and an x on bottom. Here, you have x squared over x squared, so it's the same. They're the same. So you can imagine a 1 here and a 1 here. So your horizontal asymptote is at y equals 1. So I'll go ahead and sketch that right here. So let's go ahead and graph. This whole is at 2,4/9. You could also write it as a decimal. 4/9 is about 0.44. So 2.44 is about right here. And I'm not going to draw it as a closed circle. I need to draw it as an open circle since it's a hole. Now go ahead and graph it. Go through those points. Get very close to your asymptotes. And then the other part of your graph is up here. So that is your rational function. You have your vertical asymptote, horizontal asymptote, x and y intercepts, and your hole. So let's talk about the domain. On this side, this is the left side. It's pointing to the left. That's negative infinity. And if you follow the graph, it gets very close to this asymptote, which is at -7. And then it continues right here. It starts close to the asymptote at -7. And then follow the line. It gets to this hole, which is at 2. And then it picks up at 2 on the other side of 2, and it goes to the right. So 2 to infinity. So that is your domain. Another way to write this is x cannot be equal to this vertical asymptote, which is at -7, and this hole, which is at the x value 2. So you can also write it like this. Interval work. Where is the graph less than or equal to 0? Well, let me highlight that for you. The graph is less than or equal to 0 down here. This is the part that is below 0. Everything else is above 0. So the interval, the domain of this part, the left side is at the asymptote, -7. And it's equal to 0 right here at the x-intercept. And that is the x value -2. And I'll put a bracket since you can be equal to 0. So I put a bracket there. I put a parenthesis at -7 because you can't equal the asymptote. I put a parenthesis there. So this is the domain or the interval where the graph is less than or equal to 0. Now let's talk about the end behavior of the vertical asymptote. So here's your vertical asymptote. As you approach the vertical asymptote, which is at -7, so as x approaches -7 from the positive side, so starting on the positive side, I'm going towards the asymptote. It looks like the graph goes down as you go towards the asymptote. So it's going down, it's going to -infinity. As you go towards this asymptote coming from the left side, that's what that little negative is there for. This little positive means it's coming from the positive side. This negative means it's coming from the negative side. So as I come from this direction and I approach this asymptote, the graph is going up. So this is infinity. Okay, now we're going to do the end behavior at the horizontal asymptote. So as your graph goes to the right, as your graph goes to infinity, you're approaching this horizontal asymptote. Your graph gets closer and closer to 1. And as your graph goes to negative infinity, as your graph goes this way, you're getting closer and closer to this asymptote. That's at 1. Let's try another problem. Don't let this confuse you. This says y is equal to 5 over x plus 2. Don't let this denominator confuse you because it's not in the standard form. Okay, so I don't need to factor because it's already factored. It's in its simplest form. And nothing cancels out, so that means there are no holes. Remember, to find your holes, you have to factor. Whatever cancels out, that's how you find your hole. Well, nothing cancels out here, so there's no holes. To find the vertical asymptote, you set the denominator equal to 0. So if you set x plus 2 equal to 0 and solve, you'll get x is negative 2. To find the horizontal asymptote, this is bigger on the bottom. There is no x in the numerator, it's just a constant, and you have a linear in the denominator, x plus 2. It's bigger on the bottom. So since it's big on the bottom, your horizontal asymptote is 0. Big on bottom, 0. To find your zeros, you set the numerator equal to 0 and solve. So your numerator is 5. You set it equal to 0. But when you do that, it doesn't make any sense. 5 does not equal 0. So that means you do not have any zeros. When you set the numerator equal to 0, it didn't make sense. So we do not have any zeros. Y-intercept, you plug zeros in everywhere to find it. So plug in a 0, you're left with 5 over 2. So that is your y-intercept. Your y-intercept is 5 over 2. Or you can write it as 0, 2.5. All right, so let's go ahead and graph everything. My vertical asymptote is at x equals negative 2, right here. It crosses the x-axis at negative 2. Your horizontal asymptote crosses the y-axis at 0. I have a y-intercept at 0, 2.5. All right, and that's it. So I can go ahead and graph this. I have a point, so I have to go through it. So get close to the asymptote, go through my point, get close to the other asymptote. So since this was in quadrant 1, your other part of the graph will be in quadrant 3. So this is your rational function. Let's talk about the domain. Your domain, it goes to the left forever, so that's negative infinity. And if you follow the line, it gets close to this asymptote. That's at negative 2. Then it continues over here. Starts at negative 2, and it goes on forever. Negative 2, and then forever. Or you can just write x cannot be negative 2, because there's a vertical asymptote there. Where is the graph less than 0? Well, this is the part of the graph. Let me highlight it. This part of the graph is below 0. So the domain for that part that I just highlighted is negative infinity, and it goes to the asymptote, negative 2. End behavior at the vertical asymptote. I believe this should be a negative 2. There we go. All right, so as we approach negative 2 from the right side, negative 2 from the right side, as I approach the asymptote, I go up. So this is infinity. And as I approach the asymptote from the left side, I go down. That's negative infinity. As my graph goes to the right, as the x values go to infinity, so I'm going to the right, I'm getting very close to this horizontal asymptote, which is at 0. And as I go to the left, my graph gets very close to this asymptote, and that's at 0. That's it. Here's a more harder one. You always have to factor. So to factor the numerator, your a value is not 1. So when your a value is not 1, you have to multiply a times c, which is negative 30. So you need two numbers that multiply to negative 30 and add to 7. That's 10 and a negative 3. 10 times negative 3 is negative 30. 10 plus a negative 3 is 7. So how you write this is 15x squared plus 10x minus 3x minus 2. So notice this is the exact same thing as this. I just rewrote 7x to be 10x minus 3x. This is called factoring by grouping. So if you Google this or look on YouTube, lots of videos will come up. This is called factoring by grouping. So now I'm going to divide this side by 5x. So 5x is on the outside. I'm left with 3x plus 2. Here I'm going to divide by negative 1. And I'm left with 3x plus 2. Whatever matches, that's one of my factors. And what's on the outside is my other factor. So that's how you factor the numerator. The denominator, this is called a difference of squares, okay? So the square root of this is 5x. The square root of this is 1. And you'll also have 5x plus 1. So that is how you factor a difference of squares, okay? So if you're unclear on how to factor these type of trinomials and binomials, these quadratics, you need to Google and learn factoring. This is called factoring by grouping, and this is called a difference of squares. Okay, so this is how you factor it. Those cancel out. Remember, whatever cancels out, that is your whole. So your whole, if you set this equal to 0 and solve it, you would add 1, then divide by 5. So you get 1/5. That is the x value of your whole. To find the y value of your whole, you plug that x value in to right here. So it'll be 3 times this 1/5 plus 2 over 5 times the 1/5 plus 1. So I'll show you. You're gonna have 3 times 1/5 plus 2 over 5 times 1/5 plus 1. And if you want it as a decimal, it'll be 1.3. So this is at 1.3. You can also write this as 0.2 and 1.3. That's where your whole is. Now to find the vertical asymptote, you set this denominator equal to 0 and solve. So if you set this equal to 0 and solve it, you'll get negative 1/5. Your horizontal asymptote, your exponents are the same, so it's the coefficients, 3 over 5. So y equals 3/5. To find your zeros, you set the numerator equal to 0 and solve. So if you set 3x plus 2 equal to 0, you will get negative 2/3. That is your x-intercept. For your y-intercept, you just plug in zeros everywhere. So if you plug in a 0 here and here, that's gone, that's gone. You're left with 2 over 1, which is just 2. All right, so let's go ahead and graph what we have. Your vertical asymptote is at negative 1/5. You can also think of this as negative 0.2. So that's really small. That's close to 0. I'll say it's right here. So this is your vertical asymptote. Your horizontal asymptote is at 3/5 or 0.6. So 0.6, I'll just estimate it to be here. Okay, and I'll label it. This one was at x equals negative 0.2, and this one's at y equals 0.6. We also have a 0 at negative 2/3. You can also think of it as negative 0.66. So negative 0.66, I'll estimate it to be right there. That's my x-intercept, and my y-intercept is at 0.2. That one's easy. I also have a hole at 1/5 or 0.2 comma 1.3. So 0.2 comma 1.3, I'll just estimate it to be about right there. All right, so that's everything. I'll go ahead and graph it. Go close to the asymptote, go through my point, get close to the asymptote. Close to the asymptote, go through my point. There you go. So your domain, negative infinity to this asymptote at negative 0.2. Negative infinity to negative 0.2. And then it continues on this side of the asymptote. Negative 0.2 to this hole. Negative 0.2 to the hole, and the hole is at 0.2. And then we're gonna pick up after the hole, so from 0.2, it goes on forever. So that is my domain. You can also say x cannot be the asymptote, which is at negative 0.2, or the hole, which is at positive 0.2. You can also write your domain as this. Okay, where is the interval where your graph is less than 0? Your graph is less than 0 right here. At that x-intercept to there. So that interval, this x-intercept is at negative 0.66, and to the asymptote, which is at negative 0.2. So that's the interval where your graph is below 0. So as your graph approaches negative 0.2, where this asymptote is, from the right side. So from the right side, it goes up. From the left side, it goes down at the asymptote, so negative infinity. As your graph moves to the right, so as we move to the right, it gets really close to the asymptote, and the asymptote is at 0.6. And as you follow the graph to the left, it also gets close to the asymptote, and that's at 0.6. All right, that's it.